بسم الله الرحمن الرحيم. السلام عليكم. محاضرتنا اليوم Defense Mechanism of the Oral Cavity. You know that the oral cavity is loaded with normal commensal microorganisms, whether aerobic or anaerobic. These organisms will become pathogenic if the host defense is compromised. Hence, an effective defense mechanism or immune response is necessary in order to save these attacks. So what are the defense mechanisms of the oral cavity? It can be broadly classified into saliva, circular fluid, and epithelial keratinocytes, which will protect the oral cavity from different attacks of microorganisms. However, there are several factors which may prevent the penetration of the intact oral mucosa by microorganisms as a protective barrier, which include saliva, keratin, granular layer, basement membrane, leukocytes, and different types of antibodies, whether these antibodies are IgG, IgM antibody. Talking about saliva, the composition of saliva include 99% of water, and the other 1% include antibacterial factors, salivary antibodies, enzymes, salivary buffers, and others. So what are the functions of saliva? It provides protection by its continuous fluid lubrication. Also, it has a buffering action. It can regulate the pH via the presence of phosphate and bicarbonate. The first step of the food digestion occurs in the oral cavity due to the presence of the amylases and lipases in saliva, which can digest starch and lipids. It facilitates taste. In addition to an important function of saliva is the defensive mechanism or the defensive action against microorganisms, different microbes, through the presence of antibodies, as we say, different types of antibodies, enzymes, which are lysozymes, lactoferrin, and transferrin, in addition to the secretory IgA, which is the main Ig immunoglobulin present in saliva. The last function is the ion exchange surfaces. What are the antibacterial factors present in saliva? It contains numerous inorganic and organic factors that can influence bacteria and their products in the oral environment. The inorganic factors include the bicarbonate, the sodium, potassium, phosphate, calcium, and the fluoride salt, while the organic components or compounds include the lysozymes, lactoferrin and transferrin, myeloperoxidase, lactoperoxidase, ecdysonins such as the glycoproteins, mucins, and fibronectins. Actually, all these organic substances is very important. Lysozymes is a hydrolytic enzymes and can cleave the linkage between the structural component of the cell wall of both gram-positive and gram-negative, thus lysing the target bacteria such as Veillonella species and Actinobacillus or Bacillus actinomycetum comitans, which are very important periopathogenic bacteria. The lactoferrin and transferrin can bind to the free iron in saliva, causing a bactericidal or bacteriostatic effect because some microorganisms, especially the pathogenic ones, need the free iron in order to replicate and produce their enzymes. So the presence of lactoferrin is very important also to provide a fungicidal and antiviral effect in addition to anti-inflammatory and immunomodulatory effect. The peroxidases, the lactoperoxidase, thiocyanate, and myeloperoxidase are very important enzymes present in saliva and have a bactericidal effect to some strains of the Lactobacillus species and Streptococcus by preventing the accumulation of lysine, glutamic acid, essential for bacterial growth. Also, the peroxidase is an enzyme similar to the salivary peroxidase, and it is released by leukocytes and is bactericidal for Actinobacillus species. Talking about leukocytes, the leukocytes in saliva are a large number of leukocytes and different types of leukocytes, although the principal cell are the polymorphonuclear cells. The living polymorphs are called orogranulocytes. They can reach the oral cavity by their migration through the gingival sulcus. The rate of their migration is called the orogranulocytic migration. The circular fluid or the gingival cranicular fluid present in saliva is a serum exudate secreted by the cellular or sulcular epithelium in the gingival sulcus. It plays an important role in the oral defense mechanism. The composition of this fluid is contain cellular fluid or cellular elements including bacteria, desquamated epithelial cells, and different types of leukocytes. In addition to the cells, it contains electrolytes such as potassium, sodium, and calcium, while the organic components or compounds, metabolic and bacterial products, and their enzymes and enzyme inhibitors also can be present or detected in the gingival clavicular fluid. It has also cellular immune response, which is mediated by the appearance of inflammatory cytokines such as interleukin-1 alpha and beta, which can affect different immune cells, can either activate them or downregulate them, in addition to the alpha interferon, which has a role in the diseases. What is the clinical significance of the gingival clavicular fluid? As we say, it is an inflammatory exudate, so it increases in inflammation, in addition to many other factors which affect its amount, just such as the circadian periodicity, I mean day and night, sex hormones between male and female, smoking is a very effective factor on the gingival clavicular fluid, and therapies. The epithelial cells present in the oral cavity play an important role in the innate host defenses by responding to the bacterial infections. They are either keratinocytes or non-keratinocytes. The non-keratinocytes include Langerhans cells, which is an important immune cells that take the responsibility to phagocyte the different types of bacteria and foreign antigens, and presented to the T lymphocyte, in addition to the Merkel cells and the melaninocytes also. Epithelial cells secrete a range of cytokines, including interleukin-1 alpha, interleukin-1 beta, interleukin-6, and the tumor necrosis factor alpha. These cytokines are secreted in response to the periodontal bacteria, which signal to the migration of neutrophils and monocyte to the area in order to from these microorganisms. Thank you.